Hello, problem solvers. So here is a geometry question from the APMO 1996. So we have 4 points on a circle. Okay, that would give you a cyclic quadrilateral. Let I1 be the incenter of triangle P2, P3, P4. I2 be incenter of triangle P1, P3, P4, etc. Okay, so we have 4 incenters I1, I2, I3, I4. Prove that I1, I2, I3, I4 is a rectangle. So even the diagram is a bit complicated to draw, but still, please try. I pause the video and try first. So here is the diagram. For simplicity, I just draw I3 and I4. Okay, I3 is the incenter of P1, P2, P4, and I4 is the incenter of P1, P2, P3. So actually, if you draw a nice diagram, the diagram already gives you some hints on how to do this question, a possible path. Okay, so maybe if you can look at my diagram, and that is a hint. So before we tackle the problem, okay, I want to mention some facts about incenter, which we are going to use. Okay, so let's say this point is the incenter of triangle ABC. Okay, so incenter means they are the intersections of the angle bisectors. So here I name the angles little a, little b, little c. Okay, so small a plus small b plus small c equals 90, right? Because sum of angles in a triangle is 180. Okay, so what about XC? What about this angle? This would be the sum of A plus B. Okay, and that would be equal to 90 minus C. Okay, similarly, Y would be 90 minus A. And so if you add these X plus Y, you will get A plus B plus B plus C. That will give you 90 plus B. Okay, so if this is BB, then this will be 90 plus B. Okay, that's the fact we are going to use. Also, the question says the 4 points lie on a circle, so we need to use the property of a cyclic quadrilateral, right? So that tells us that this angle, for example, is the same as this one. This one is the same as this one. This one is the same as this one, right? And so on. Okay, so I will use XY, to denote these angles in the figure. Okay, so that is the preparation. Let's begin solving the problem. So my solution is quite elementary, I would say. The technique is called angle tracing. You just find out all the angles. Okay, so let's say I have these I2, I3, I4 here. So for example, if I can show that the angle I2, I3, I4 is 90 degrees, of course my argument will apply for all 4 angles of I1, I2, I3, I4, and then that would show that this I1, I2, I3, I4 is a rectangle, right? So basically, you just need to show one of the angle is 90. I2, I3, I4, this angle is 90. Okay, that's what we need to show. and then by similar arguments, all four other angles will be 90, and that just proves that it is a rectangle. Right, so that's the plan. Okay, so how do we actually prove it? Just calculate all these angles near I3. Okay, that's what I'm going to do. So using this fact, you see, okay, this angle is 90 plus half of this angle. Right? This would be this would be 90 degree plus half of angle B. Right? This is just 90 degree plus half of angle B. So that tells me P1, I3, P2 would be half of 90 plus half of this angle, which is XE. Okay, so I know this. Earlier, the angle P1, I3, P2 is 90 plus half of this angle, which I call it X. Okay, we hope that these 4 points is a sacred quadrilateral. Okay, in that case, this angle P1, I4, P2 should be equal to this angle, and indeed it is. Right, using this fact again. Right, these are the angle bisectors. Right, and this angle P1, I4, P2 would be 90 plus half of this angle, which is also X as well, because P1, P2, P3, P4 is a sacred quadrilateral. These two angles are the same. Okay. Since these two angles are the same, that tells me these 4 points is a sacred quadrilateral. P1, P2, I4, I3 is a sacred quadrilateral. Okay, and so this angle I4, I3, P2 is the same as I4, P1, P2, which is half of W. Okay, so that means angle equal to I4, P1, P2, which is half of W. Okay, I call this angle W. P3, P1, P2 is W. This is half of this angle. Okay, so we have successfully find out this part from, I know the angle P1, I3, I4. So now all together, angle P1, I3, I4 is equal to this angle, which is 90 plus X half, plus this one, which is W half. So altogether, it is 90 plus W half plus X half. Okay. Actually, we are almost done, because this argument is generic. We can apply the same argument to this side. Okay. So similarly, angle P1, I3, I2 would be equal to 90. So you see, this one corresponds to this angle, this whole angle. Then by analogy, this one would be the same, would be this angle. If this angle corresponds to this, right, x plus w half, then this one corresponds to this one. Okay, what I mean is this will be half of z plus half of y. Okay. Again, for this channel, I don't plan to write out every single detail. Okay, because that would make the videos very long. But on an exam, on the real exam, you should not do this. You should really try to write out all the details. Okay. Well, you can try to verify this part. Okay, and so what do I get out? So these two angles. So now I can calculate I2, I3, I4, right, which is 360 minus these two, and you can see that after some, you can see that it is 180. It becomes 180 minus half of all four angles, right? But what do they sum to? W plus x plus y plus z times 2 is 360. Okay, so w plus x plus y plus z is 180. That is 180 divided by half is divided by 2 is 90. Okay, so we have reached the conclusion that I2 angle I2, I3, I4 is 90. And of course, the same argument applies to all four angles. Okay, and probably you don't need to, you can just, even on the exam, you can just say similarly. Okay, angle I3, I4, I1, angle I4, I1, I2, angle I1, I2, I3 are all 90, and so I1, 2, 3, 4 is a rectangle. Okay, that's the, well, I show you the main idea, right? I left out some details, but that is what I'm going to do in this channel. Okay, again, every time you solve a problem, you should reflect on what's the crucial step that you help you to solve it. Well, there are several in this case. First of all, you need to draw a good diagram. Okay, because this is quite complicated. You need to know which lines to keep, which lines to draw. Okay, so that you have just enough detail to do your deduction. Right? If you just draw every line, it will be super complicated. Okay, so I guess the hardest part of this problem is to realize you can actually calculate this angle to be 90 using some simple elementary facts. Okay, not all mathematical Olympiad problems are solvable simply by angle chasing. sometimes you need to make use of length as well. Those are the harder geometry problems. But this one you can just solve it using angle tracing. So that makes this problem not so difficult, but it is complicated. Okay, yeah. So the main difficulty lies in the complexity of this problem, of the diagram. Complexity of the diagram. It took me quite some time to find out. Actually, I can just find out the angles without other stuff, without using other properties. Yeah. So to conclude, what would be the difficulty score? Well, I would say this is like a mid-range, low and easy to mid-range difficulty of a national Olympiad problem. So I would say the difficulty is about 4 or 5. Maybe 4 out of 9. And this difficulty corresponds to Gaara. Okay. Yeah, let's put him here or here. Okay, thank you for watching.